Hi everyone. Sorry it's taking a bit of time. Getting these things set up is difficult. There's a lot of kit I've got with me today, so, and I've got another talk later on as well, so it's quite heavy, isn't it? Right, once this Prezi loads, we can start. So, yeah, as the gentleman said before, I'm from Samsung Research, and I'm based in West London, near Staines. And this is a talk on using progressive web apps to work with IoT. And I'm going to look at just one specific aspect of that because it's a huge area. And this is taking ages to download. It's a huge area of research. But so today what we're going to look at is progressive web apps with IoT, and we're going to just look at one of the problems you've got with the Internet of Things and progressive web apps. I have got a PDF I can use, but we tried this last night and it worked fine. I'm going to use FOSDEM Wi-Fi. Right, I think I might go to my PDF. Right, I'll get a PDF up. Wow. Jesus. Yeah, that's me. Right, so the URL for this, the code we've got here is there. You can get, there's a link in the FOSDEM website, and you can just go and have a look at it. It's not even alpha, it's just raw, and I'll tell you about it later. So yeah, that's me. I'm going to rush along a little bit. So my slides usually have little icons at the top, and you can see at the top right, top left, top right, sorry, you'll see what I'm talking about, so you can understand if I'm talking about the overall thing, I'm talking about, you know, how the thing works, and so on. Right, so something unbelievable. The average web page is about 3 meg in size now, so that's huge. To put it in perspective, Doom was 2.9 meg when it came out, the game. And this thing here, the launch vehicle digital computer, weighs 32 kilograms. It's triple redundancy, and that took man to the moon. That was on the Saturn V space rocket. And you could fit the memory footprint of that almost 100 times. I worked this out yesterday. 97 times you could fit that, the memory of that machine, into your standard web page. So you can see that over time, web pages have become, or the web's just become power hungry. So what kind of problems have you got with IoT and web? So for me, IoT is all about small, tiny, connected devices. I've got one right there, the light, and that's got a Raspberry Pi Zero in it. And it's how you connect to those devices. That thermostat could be an IoT device. Anything around you, the speakers, they could all be IoT devices and they could all be connected. And they're usually low power, low bandwidth. They don't have much resources at hand. And then if you look at the web, this kind of went the other way. These phones are so powerful now. The rendering on them is incredible. There's some of the phones here, that phone there, has got more graphical processing on it than your large screen televisions. So that's incredible. So the Samsung TVs, the big ones, have got a less powerful graphical processing on it than your modern phone. So we're talking about PWA and IoT, so I can't go into lots of detail. All the slides are there, and you can talk or email me if you want to go into detail about some of the things. But for me, we're going to talk about PWA, and you guys probably know more about it than I do. But we're going to talk about in respect of IoT, PWA, and why it's so cool, and the demo, if it works. I was working on it last night and I nearly broke it. And controlling an IoT thing with Bluetooth Low Energy, and a breakdown of how you control these IoT things. Right, so PWA, you guys have probably seen this. What is progressive web app? What makes it a progressive web app? And there's 3 things you'll see everywhere. There's more than that, but these are the 3 core ones that I've seen. And they're talking about you need HTTPS. It's got a web manifest file, and there's a thing called a service worker. But that's great. Why are those things there? What do they actually mean? And that's quite important when you talk about IoT. So I always wondered, why do they need this HTTPS thing? Because it's still to do with the service worker. The service worker is taking information from your web page, it can be any web page, and it's manipulating it, it's changing it before you get to the outside world. So your backend server could be there, and this service worker can route and do quite a lot of stuff there. I'll go through that in a minute too. So the main point is, if I'm going to put something here that's a progressive web app and it's going to control something, a Samsung thing, when someone else puts another Samsung-like web page with a look and feel of Samsung thing, and you download that, and you've given the application the power to do almost anything. So you need to be damn sure that when you run that progressive web app, it's coming from the right place. Makes sense. And the web manifest file, again, this is the key point, is how you describe that progressive web app. And there's a really good link here that I encourage you guys to go and look at and find more about how you construct your manifest file. My manifest file is really small, and it's meant that way deliberately. And the service worker, so this is the kind of key thing for me that defines a progressive web app. It's how you're going to try and do more than just serve up web pages. So obviously it's a JavaScript in the browser. It's separate from the web page, so it's not just working with that single page that's there. And you can do things like push notifications and background synchronization. So again, you're acting more like an application than you're a kind of typical web site. So it's become more of an application environment. And you've got your client-side programming network proxy. So that's the guts of it. You know, you can actually route requests coming from that browser and web page and go anywhere. Yeah, so in your web page you could say go to X, but you actually don't know why, or not going anywhere at all. And you have access to a database. That's key as well. So you can put state in this thing, and so when you launch it again, you've got a state control mechanism there too. Right, this is out of Wikipedia, so you guys might know this already, you might not. So this is the kind of definition of the Internet of Things: a system of physical object connected to the Internet that can be discovered, monitored, controlled, or interacted with. It's quite succinct, it's quite exact, but there's a whole load of interpretation there, because you can have a thing that's connected via cellular, Wi-Fi, LoRa, Sigfox, nothing at all, Bluetooth. So there's a whole vast array of different IoT things that you could talk about. And the challenge we had in building IoT things, so in the lab we'll build stuff, and the typical thing we have that's the problem is trying to get connectivity to it. So you take that thing out, you get it configured, and you move somewhere else, and it doesn't work because you need to get a Wi-Fi address to it, or you need to somehow get the configuration details onto that device. So the configuration is the main crux that we see in IoT, because you can move them anywhere unless it's screwed on a wall. And it doesn't have a screen, doesn't have a keyboard, it's just a thing sitting there, and somehow you need to get connectivity to that device. So the way to do that now, if you can buy one, if you've got these kind of web connected speakers or anything that has this kind of IoT look and feel, usually what you do is you press a button on it and it'll come up in a kind of standard default mode, and you download an app, and then the app will configure the device. So how that works is the device will switch to an access point mode on the Wi-Fi system on the device. So it's an access point, and the app you've downloaded will then push the details of your router to the device. That's great, that's fantastic. I saw my wife throw one in the bin because 2 years later we changed the router and it never worked. She can figure out why it didn't work. When you turn it upside down, you have to press a reset button and get back in default mode. So this whole thing is really clunky. If you want to try and configure something, it's a real clunky way you've got to go about this. Right, and the demo. Right. I might have broke it last night with the thing. We'll see. I've got a free Raspberry Pi Zero. Does anyone want a free Raspberry Pi Zero? And come up and do a bit of a demo. So someone got a phone. Yeah, what's your name? Peter. Right, I'm Nicholas. Have you got your phone? No. Ah, okay, use mine. I typically want to.
Do I need to come up?
No, yeah, I was wanting someone on a phone, but it doesn't matter. Yeah, you can come up. Why not? Right. So. Yeah. So, pretend this is Peter's phone.
This one is tested already.
Yeah.
I'm like Richard Stallman, I do not do mobile phones.
Yeah. Right. So, what I wanted to do, that anyone can do this in the room actually. If I could get cellular working. Oh my God. Right, so can you see that? So you go over there, right, when this finally comes up. So what we're going to do is, I want you to imagine you've got this connected device, your light, which, please let it work, we're going to get Wi-Fi connectivity to that device, and then I'll hopefully get an SSH onto it and prove that it actually works. And one of the key things of demos is they always go wrong. Right, so this web page at the top here, which Peter's going to click a button, is the thingsdemo.samsunginter.net. Yes, right. So there's the same thing, right? So if that took that long, that's going to get a problem as well, right? Okay, so Peter, can you connect the device? So right away, so first of all, before you click anything, it's displaying an IoT gateway. So it's actually found the device. It's really poor signal as well. So it's found the device, we're going to pair with it, and then hopefully the device is going to report back all the Wi-Fi points it can find. And remember, that device doesn't actually, it's not connected to anything yet. We've got this default device. We haven't downloaded an app. There's nowhere you saw me download any application there. We just went to web page. You want to pair it? So pair and then pair, and then, oh God, right, yeah, okay. Oh, my demo's not working. It's a demo gone. Oh, here you go. So, right, select, right, hit select there. Right, okay, right. So now we've got a list of Wi-Fi access points. And click next is because I know that there's only me on that one. So that's right. I was going to get you to this. So, and then the password is test 1 2 3 4.
Okay.
So, yeah, no,
Test 1, 2, 3, 4.
Yeah. So this will work on anybody's phone, but don't do it yet. Okay. So, God. Right, so now if it comes up with a success, I know that that thing is connected. Yes, it worked. Fuck. Right, so there's the whole demo is just showing you that we didn't download any app. We just went straight to a web page, connected to that, and then we'll provision it with a Wi-Fi access point. And the key point is it's seamless. The user didn't go away to some Bluetooth thing. They didn't go away and download an app. They just went to the Samsung web page and it found that thing there and it connected. So, and I'm going to give you a Raspberry Pi. You need to give me your name and address, and I'm going to send you one. Or I can get.
I will do it afterwards.
And okay.
No problem.
Thank you, Peter. Yeah. Don't connect. So if you actually do continue, what's going to try and do is going to try and take you to the application web page, and that's part of another demo which usually connects to a gateway. And the gateway's not here, so it's going to fail. But that's what would have happened if we had the gateway there. And thank you for helping me with my demo. And I'm hopefully out of time. So that's the demo, but how did I make that work? So I like to do the demo at the start because then if it goes wrong, you can move forward it. And if it goes wrong at the end, it's crap. So the demo worked, just about. But now you're all interested, I hope, in how this thing actually worked. So again, so there's a nice little diagram here I've got showing the website here. You're downloading your progressive web app, and then you're getting this default page up that you saw already. And then you paired it with your device. This is a Raspberry Pi Zero that Peter's going to get for free. And then you went to your settings page. And remember, that was all of Bluetooth Low Energy. And I'll hopefully show some of the code as well. And we're not going to go through that. That's how the actual light works. And we're not going to do that or that. This is all about deep IoT stuff. But what did I use? And there's another key point here. I didn't use Angular or React or Vue. I used Svelte and Sapper. So there's key differences between these frameworks to what you get with React and Vue and Angular. So Sapper is the kind of server-side part of it, where you can build your service. And the key points you're using Sapper as opposed to Angular, React, or these other frameworks is you've got server-side rendering. You don't download a runnable block of JavaScript. You're not downloading the whole framework. You're just downloading the raw JavaScript to your page. It gets rendered server-side. Your code splitting, so you only download the piece of code you need as you hit that page. You download the bit of code that you want, not the whole thing. Scope styling, decorative routing, live reloading as well. That's problematic. So I think there may be problems with that. It's very fresh, this framework. But the key point is it was really quick, even on an edge network. So I've only got edge here, and I've got 5 minutes. It's 10 times faster. And Svelte is the UI part. So Svelte was the thing that gave us a UI, the UI rendering. And I'm not going to get time to go through that. It's a UI engine. It's faster than React, Vue, Angular, Ember, or Riot. It's got a cool widget system built into it as well. And go there. There's really good guides and really good explanations of how you can use this system. It's really quick to set up, and I was hoping I was going to do that. But yeah. And then the other part of the system is the part that's in the light. So the light's actually got a little IoT JavaScript, it's all JavaScript thing that's doing that. So the parts that we've put in, these green parts, the parts we've done, we're using these libraries, the Pi Wi-Fi library, Node.js underneath the hood. We used BlueZ to get the Bluetooth on that. And then we used Bleno over BlueZ, and we used Pi Wi-Fi, so that Wi-Fi controller, which we put that in there, so we've got a layer that we can swap out. So if we put this onto another bit of hardware, we can just change this bit here, the Wi-Fi controller, and it still works, hopefully. Yeah, it's bleeding edge, so there's bugs in it and But if anyone wants to contribute and think it's a good idea, please do. And the sequence diagrams, I'll put these all on the GitHub as well, if they're not there yet. So we've actually done a proper design of the system and how it would work. So again, you've got your client device, the website you're going to put your progressive web app on, and then your Bluetooth Wi-Fi manager, which is on your embedded system. We're using the Raspberry Pi because it's cheap and easy. Anyone can try it out. So you download your web app, you get your HT response from there. Then this is where your loop comes in for the Bluetooth scanning, and we're using GAT attributes for Bluetooth. If anyone knows Bluetooth low energy, have a look. Then we get your Wi-Fi setup page, which you saw already in the demo. And I'm going to miss that one as well. It says more details of all of the network flow that you got from here to here. So even though you only saw 2 or 3 pages, there's quite a lot going on underneath the hood to get that to work. Yeah. So you just saw 2 or 3 dialog boxes. And again, at the end up, we had the password characteristic being set across over the Bluetooth interface. And hopefully I'll get questions on security at the end. And then we had the dialog box at the end showing you the connect page. And then finally we missed that piece out because it would fail. We're getting the response back with a redirect. So you can design this how you like. So we're just doing we do a redirect to a gateway, which I don't have here. And how much time have we got left? Right, shall I try and get onto the light and just prove that it really is working? Shall I do that? Okay. So I'm going to get onto my hotspot. How many minutes we got left? A few. Okay. My God. Right. Yes. I didn't even show you the code, unfortunately, but the code is on the GitHub repo, and there's 2 sections to it. There's the web app thing, which is on the web app, and then you got the Bluetooth low energy stuff, which goes in the Raspberry Pi. The README files are fairly okay, but I'm going to expand on them and make them better. It's bleeding edge. There's bugs in it. But it's something that may happen in the future. It doesn't work in all browsers yet, so you don't expect this to come up on your next Samsung product. It may be 1 or 2 years down the line before this kind of thing happens. And have you got any questions for me?
So you'll have a bunch of questions just outside of the room, so you can spend all the time you need. But for
Thank
all
you
those
for your time.
super precious questions, thank you.
Thanks.